we just started with, did the kids know, I know, I'm gonna fix the board in a second, where the basic log was. My question now is, what would move the asymptote? Not every change. Would a multiply move the asymptote? No. Talk to the kid next to you. There's really only one thing that would move the log's asymptote. Talk to the kid next to you. What would move it? All right, and it would be inside the parentheses. All right, so everybody be with me. I don't want to yell at anybody for not being with us. Hint, hint. All right. Okay, so if you had a log with something on the inside, y equals log base 2 of x minus 3, something on the inside like that would move it. Okay, so that would move the asymptote right 3. I'd like you to take this one. This is a very easy one, honestly. So in fact, it's too easy. I'm going to put a times by 2 in the front of it. And that brings it up to about the level we would test you at, where there's 2 changes to the parent function. Would you please tell me I know this one's going to move. And I don't want you to just tell me it moves and it stretches and it whatever. I want specific points. Where exactly is 3 points that would be on this graph? You're supposed to have this down, but I understand these are hard. Make an XY chart. Start by putting in like 0 and realize, well, that actually doesn't even work. So 3 would be a good start. And you might say it doesn't work, but 3 would tell me something. Do you guys remember that if you put in 3, that actually gives you the asymptote? And it also means that you're really close to numbers that work. Like 4. 4 does work. And why does 4 work? Because when you put a 4 in, then this part becomes 1, and you got a 1 in the argument, you get a very simple answer. You win the argument, you get nothing, which is 0. And then you still times it by 2, and it's still 0. So I put in a 4, and I get 0. That's one of your points. Please, there's 2 more logical points. There's really only 2 more. Because any other, after that, they get really big numbers that you wouldn't be able to graph. So hint, I told you how to find the fraction one. You'll probably need to find that here. Now, if you can get 2 more points that fit on the graph, I'm okay with that, without doing the fraction one. But if you can figure out the one that's a fraction, that's even better. All right, so we tried 3, and it kind of worked. Gave it the asymptote. Tried 4, it worked. Now, duh, you're going to try 5, and then you're going to go, does that work? Does it? Yeah, 5 actually works pretty good. How do you know if it works? Well, because when you put 5 in, this part is a 2, which matches the base. Log base 2 of 2 is supposed to be an automatic for you. And we're going to go through some of those to make sure they're automatic. Log base 2 of 2 is 1. Don't forget the times by 2 in the front, though. Final answer is 2. I put in a 5. I got 2. And there's probably just 1 point left. That would be like the logical one to pick. You don't have to do the fraction one. I can see now that these numbers will stay small enough that you can probably get 3 points without the fraction one. But I'd like you to prove that you either know how to do the fraction kind or not. So, 1 more point that's like should be pretty easy. Compare that. And then if you can do the fraction kind, would you please tell the kid next to you, what fraction would you put in to get another nice point? All right, I'm going to pause while you talk that over. The easy point and then the fraction point. Okay, so here's the 2 points I was talking about. We tried 3 and it kind of worked because it gave us the asymptote. And then we tried 4 and 5 and they both work. 6 does not work so good. I mean, 6 minus 3 is 3. And log base 2 of 3, nobody has that memorized. So then I try 7. And 7 minus 3 is 4. And that works nice because log base 2 of 4 is nice. And it's easy and it's 2. And then you times it by 2 and you get 4. So I put in 7 and I got 4. That's probably the other normal point you would have used. But there's a fraction point. If this whole thing were to be a 1/2, then you'd have log base 2 of 1/2. And that would be pretty handy. See, log base 2 of 1/2 is one that's supposed to just be automatic for you. You're supposed to be able to go, oh, that's 2 to the -1, so the answer is -1. See, if you get it like this, the answer is -1. So what could I put in that would make me get a half? 3.5. Who figured out it was 3.5? Nice, a lot of you got that. So 3.5 would work pretty nice. And what would actually come out? Well, you get a -1, but you times it by 2, so then that would be -2. Sometimes that's necessary. So I'm trying to teach you enough so that if you get a really hard one on the test, where it's going off the graph, then you know how to do that. All right. Now let's go over some of those things that should be absolute, like super fast, easy, no-brainers. Like if I say log base 3 of 3, the research says you should give the person 3 seconds. And then if they don't know it by then they don't have it memorized. Well, you should memorize when the base is the same. You should know what the answer is. So I've given you way more than 3 seconds. So on the count of 3, I'd like you to all together say what this is. Here we go. It's not on 3. It's 1, 2, 3, go. Okay? 1, 2, 3. What is it? 1. All right, good. I'm going to start changing things, and you should be able to still say them. I'm going to give you 3 seconds. 3. What if I put a 1/3 right there? Don't say it. You have 3 seconds. 1, 2, 3. What's that one? -1. All right, good. What if I put a 27? 1, 2, 3. What's that one? 3. All right. These should be automatics for you. Now, I know this is going to be harder for a lot of people, but you should memorize this one if you haven't already. Log base 4 of 64. Ooh. 1, 2, 3. What do you think it is? 3 is correct. The reason, some of you didn't know this, is that that's 4 to the 3rd. Okay? And that's why the answer is 3. Okay. Here's another one. If I give you 3 seconds, you'll either know it or you won't. 1, 2, 3. What is it? 3. 3 is correct. Good. How about log? This is a harder one. I'm going to give you more than 3 seconds because this one will stretch you. You should be asking yourself, could I make the 2 into a 1/8 to a power? All right, take a second, write this one down, and try to figure out how you could make this into 1/8 to the something. Those are hard, but you can do it. First, you want to get the 2 to scale up to be an 8, and then you won't be quite there, but you'll be close. What power is this? And that whatever that power is, that's the answer. Talk to the kid next to you. What do you think it is? All right, a lot of you got it. I can hear it. -3. So how do you do that again? You take the 2 and you think, how can I make it into just an 8? And a 2 into an 8 is a 3, 2 to the 3rd. And then that's just going to give you an 8, so you want it to be a -3. All right. And if you can do that then you simplified this whole thing to a -3. You can just cross it all out and write -3. That's what that means. This whole thing equals -3. So if then the problem said equals 5x, then you'd be saying, well, then -3 equals 5x. And then to solve that, you just divide both sides by 3, and the answer would be -3 over 5. That's what today's problems are like. They're solving problems. And if you can simplify the log part, then the solving part is easy. It's about, can you simplify the log part? All right. So there's a whole bunch more little things I just want you to know. 4 to the what is 64? Don't say it. Think it. Think it. 1, 2, 3. What do you think it is? 3 is correct. Good. How about this one? 81 is 3 to the something. Don't say it. Think it. 1, 2, 3. What do you think? 4. Yes, 3 to the 4th is 81. You should memorize that one. How about 5 to the something is 125. Don't say it. Think it. 1, 2, 3. What do you say? 3 is correct. Good. All right. Now there's a weird fraction one. You know you got tested on this, but you know they're hard. I'm going to give you more than 3 seconds, but... So first you do the root part. This is a normal power, and that says to flip it officially math-wise. Now inverse. Inverse is what that means. Okay, so you got the answer. 1, 2, 3. What do you say? Not many people answering. All right, so how about this? Remember, you were tested on this. That doesn't mean you know it, but it means that it shouldn't take long to relearn it. What is the third root of 27? 3. What is 3 to the second? 9. And then what does this mean? Flip it. So what's the answer? 1/9. Could you do that? Typical question on a test. But you might be able to test last unit. Yes, math does that. Can't just let go of last chapter. All right. Here's one more that's similar. 81 to the negative 1/4. Don't say it. Think it. The fraction. 1, 2, 3. What do you think? 1/3. If you didn't know this one, you haven't memorized the 4th root of 81 yet. It was up on the screen just a second ago. It's 3. See, 3 to the 4th is 81. All right, you maybe want to write that one down. If you just got that wrong, it's going to come up on the homework, and you're going to be, oh, I don't know what it is. 3 to the 4th is 81. You need to know that one today. All right, and once I got that answer, which was, again, 4th root of 81, which is 3, then I go 3 to the 1, which is still 3, and then it's flipped, 1/3. Okay. All right. Another thing that should just be automatic for you. If n to the negative 1 is 5, what's regular n? How do you get the n alone again on this kind? On this one, I'd like you to write it down. Just write the problem down. And talk to the kid next to you about what do you do to solve this. Neither of you know. I'll come over and help you. Most groups will have somebody who knows. You're putting it to a power is my hint. Putting it to a power of. All right. Who knew that you're putting it to the power of -1? Raise your hand if you knew that. All right. That's only like half the class. Some of you guys noticing that you're behind? If you're like, good Lord, I haven't been able to answer like 6 of the last 8 questions, you need to come in the morning. I'll work with you. But if you're getting that far behind so that you didn't know 6 of the last 8 questions, talking to whoever that is, please come in. All right. Those two multiply out to 1. That's why this works. N to the 1 equals, and that's just n. And 5 to the negative 1 is just flipping it, 1/5. All of these little skills come in today, and if in the middle of the problem you don't know that, you can't do the problem. So I'm just trying to remind you all these little skills so that when we're in the middle of the hard algebra problem, you know, oh, I know how to get rid of that -1 power. I'm just going to put it to the power of -1, and that turns it into a power of 1. All right. And then here's the last blasts from the past. X squared minus 5x. Let me think what I should do here, because it equals 6. You have a quadratic to solve today. You had a whole unit on quadratics, but it was back, way back in first semester. It wasn't even at the end of first semester. It was like in the middle of first semester. Do you remember how to solve this? You know you learned this. You know you had a whole test on quadratics. But you gotta keep some things fresh. That's one of the biggest challenges, I think, in math, as a math teacher, is you get it, you learn it, you test on it, you probably got that, and then a month later you've forgotten some of it. In fact, a lot of it. And then you just don't know what for sure. I mean, we all know you're going to forget stuff. We haven't been really clear with you on what is the crucial thing that you got to keep practicing. So I think we should have some sort of like review worksheets that weave in and remind you of this stuff. Like that was the really important stuff that's going to be on other tests, you know? I think we should weave in the review throughout our curriculum. Okay, so here's what you should have remembered. You got to set it equal to 0. I'm curious how many of you remembered that. Looking for hands. A lot of hands. Yay. And then, did you know what to do? The next step is you factor it. X and X. And since the last number is negative, it's a plus and a minus. And then it would be a minus 6 and a plus 1. And if you're not sure why, try multiplying it all the way out, and you'll see that the outside and the inside are the key ones, and they make negative 5x when you do that. And yay. Then the answers are x equals negative 1 and x equals 6. Who was confident they would have had that if the test was today? All right, thanks for being honest, some of you. If you didn't have that down, you need to have it down now and for our next test. I'm not just reviewing this for fun today. It's something you have to know. This is a big one. Factoring's huge, and setting it equal to 0 is huge. All right, so now we're actually ready, after all of that, to teach you the new stuff, which is you get this equation like log base 3 of x equals 4, and this is a fairly easy one, and they're just going to say solve for x. And what you don't want to do is just guess and check, because we won't give credit for that. You've got to show work. So how do you solve this? I'm going to call this process, I called it the circle of logs, and I'm also going to say you're rewriting it. Watch what happens when I go 3 to the 4th equals x. What's different about that? The x is alone. I've solved it. That's what it means to solve it. Is the x is alone. I've solved it. As long as I know what 3 to the 4th is. What's 3 to the 4th? 81. If you had to, you can go off and put 3 times 3 times 3 times 3, and you could do it. It wouldn't even be that hard, because 3 times 3 is 9, and then the other 3 times 3 is 9, and then that's 81, right? Okay, cool. That is about as easy as they get. Of course, they're going to get more complicated. So what if it's, write this one down, log base x of 3 equals 11. The first thing you should think of is rewrite. Circle of logs. Aiden, x is how you start. And then what?
And you put it to the power of 11.
Good. X to the 11th equals?
3.
Good. Now, it might feel like a fail because x isn't alone, but you just have to take one more little step. You're going to put it to a power of 1/11. We had a problem just like that on your last test. You should be able to do that. Who had 3 to the 1/11th? Nice. See, x is alone now. Yay. Wait, is this one of the kind where you have an absolute value? Do you remember that nasty little trap? Now, we actually ended up making last test easier than it could have been. I think we should have put one of those on there. But this is to the odd power. You know, the bottom of it, the root, is odd, so this does not have the absolute value. If it had been a square root, like a 2, 4, 6, 8, then we would have had absolute values. So, okay. So now, there's a catch on this one. If you start rewriting it right off the bat, you lose. You cannot just go at or 2 to the 5th equal, nope, it won't work. What's different about this one? The 4. How do you get rid of the 4? There's 2 choices. Yes? Dividing by 4 on both sides is probably the easier way, yes. Now I want to stop right there for just to say, well, what's the other way? if you weren't going to do that. You could move the 4. And I noticed a fair number of kids learned that from the video that played on Monday because I was gone. Do you remember where you could move that 4? You could physically grab it and move it somewhere. On the X. Very good. Now, I'm not saying you should do that in this case, but you could. We're going to use that property more and more. That number that's in the front can go up as a power on the argument. It can be done. And then you could rewrite it. All right? I'm actually going to finish the problem this way because I think it might actually be slightly easier this way. 2 to the 5th equals x to the 4th. And you keep asking yourself, did I get the x alone yet? No. So then how do I get the x alone? Isaac, power of?
1/4.
Correct. And then that means, ooh, is this one of the kind where I have absolute value? It is, but let's not even finish it. Final answer is 2 to the 5/4 and negative 2 to the 5/4. All right. And that brings up another vicious twist, which I don't know if we're going to do to you or not. I'm trying to be honest. I don't want to tell you all the test questions ahead of time, so I try not to look. But I know what we could do. Do you get that has 2 answers and one of them's negative? Do you remember that deal where sometimes there's an answer that doesn't actually work? I warned you about that over and over for the last test, and then we decided to make it easier and take that off. So a lot of you were like, where's the one that doesn't work? There wasn't any that didn't work on the last test. But they're going to be eventually, and for sure in pre-calc happens all the time. We got 2 answers for this. X equaled 2 to the 5/4 and negative 2 to the 5/4 because of the absolute value that came around the x here from the root. All right, so if there's 2 answers you look at, and especially be suspicious of the negative ones, because look, if I put it back in the original problem, and that 4 was down in the front there, it wasn't up there at the beginning, I have a negative in the argument, and that is illegal. So watch out for that. This one, even though it's a right answer, it's an extraneous answer, meaning you did everything right. You should have got negative 2 to the 5/4, but it doesn't actually work when you put it in because you can't have a negative there. Whew. Man, I did sign up for an honors class. This is one of those moments where that is so complicated. Yeah, we wouldn't do that in the regular higher algebra class. But we would in your test. Watch out. If you ever square root both sides, absolute values, get 2 answers. Sometimes one of them doesn't work. All right, I think one last thing I got to tell you is how to add logs together. Everybody write this down. Log base 3 of x plus log base 3 of 5 equals log base 3 of, let me think, let's make it 20. Okay, there's logs all over the place. So here's some rules about logs that are not true about other numbers. When you have logs, if you have 2 of them, you should always put them together into one log. You can do that. You don't know how yet, but I'm going to tell you. These 2 log base 3s, they can just be one log base 3. They can mush them together. Combine them into log base 3 of something. I'll give you this hint. It is not x plus 5 in there. You might think it would be, but it's not. But of course, x and 5 are in it. Now, if I tell you that much, what do you think I have in there? 5x is a good gut feeling. You are correct. When you do when 2 logs get added together, like this, they combine into one log, but the arguments get multiplied. All right. Next thing about solving logs is that if you have the same base, do you remember that thing? I've said it like so many times. If the bases are the same, the answer's already there. Bases are the same. So this must equal this. 5x must equal 20, and therefore x equals 4. So when you have 2 logs, put them together. If the bases are the same, The answer's already there. There's my best clues for you. Now, this next part, we're going to actually dig into the worksheet together. It is way too long, and so we are going to just do the evens. That is literally cutting it in half. That is me trying to say, I respect that you don't have an hour for math every night. I'm going to make it more reasonable. But doing some homework is way better than doing none. Now, what if you get a couple wrong? Maybe you should go back and do a couple of the ones you skipped. But it's on you then. Aiden, would you read me? Oh, there's two Aidens. Corner Aiden, would you read me number 2? Start with log base. Nice. Now, is x alone yet? No, that's the whole point. Carlos, you know what to do? Nice. X to the equals. And just a few minutes ago, a lot of people sat there stumped on this problem. Here it is again. Putting it to the power of -1, right? Why? Because this part makes it 1, and that's just x, and then that's 1/15. Danger, if you left it this way, I'd have to mark it wrong. Why? Because you're not allowed to leave answers with negative exponents. We have never, you may not have noticed this, but we have never had an answer on any worksheet or test where you leave an answer with a negative exponent in it. So you have to simplify that, and you have to know that that's 1/15. All right, here's number 2. Number 4 is also actually not real fun. Joshua, would you read me number 4?
Log base 9 of 1/27 is equal to 5x.
Equals 5x. Nice. Now, if you are a ninja with fraction exponents, you could turn 1/27 into 9 to a power. Some of you are that good, and you can do it that way. But I don't think most of you are that good. So most of you, I would go 9 to the 5x equals 1/27. And then you definitely should get it from here. Do you get that they both can have a base of 3? Remember this kind of problem? You had problems just like it on the test. They haven't gone away. 9 is really 3 squared. 27 is really 3 to the something. If you don't know, you can maybe ask the kid next to you. And the point at the end is once the bases are the same, the answer's already there. It's just up in the exponents. So at the end, this will look like 3 to a power and 3 to a power, and the answer will be whatever the exponents is. It has to be set equal to each other. All right, from here, I want to set you free. I'm hoping that you will first look at the key. And I'm hoping if second you don't get it, you've asked the kid next to you, you know, talk to them a fair amount. I'm hoping you'd trust them enough to say, I don't get number 3. You know what to do there? And if they don't know, then you come up and ask me. All right? You don't have to do all those steps, but for sure look at the key at least. All right, that's all I got for you for today.